Hello everyone. So our next section is on solving log equations. So you still have to remember all of your log properties. So if we're adding two logarithms, we can multiply their arguments. For subtracting, we'll divide the arguments. And don't forget, exponents on the argument can be brought out front to be a coefficient or vice versa. If you have a number out front, we can make that an exponent on our argument. But for all of these, you're going to see x's in there, and we want to solve for x because we're solving equations. Okay, and I made two videos for this set of notes because there's actually two different types of equations here. In total, we're going to be looking at 4 different types of equations that use logarithms or start out with logarithms, but they're all going to be log equations. And you will have a calculator for this test. Anytime your answer is a decimal, we're just going to round to 3 decimal places. I don't think we have any decimals in today's answers, but you will in our next set of notes. So just remember, anytime you get a decimal, 3 decimal places, just like we did on our last test. Okay, so the first type of problem you're going to see is when you have a logarithm equaling a logarithm. Okay, now it might not look like this to start with. You might have other things going on, but that we can get it down to this form. If we can get this to happen, a logarithm with the same base, see they're both base A, if that is true, then we can say the arguments are equal to one another. Now this is a property of logarithms, okay, but don't think of it as you're canceling the logs or you're dividing by a log. That is not what's happening here. The property says that if log base A of x equals log base A of y, then x must equal y. So if I have this equation down here, log base 4 of x plus 4 equals log base 4 of 10, since it's the same logarithm and I have nothing else going on, I can say x plus 4 equals 10. So I'm just using this theorem, log equals a log, there's my equation, and now I can just solve for x by subtracting 4 from both sides. Now for every single problem on this test, anytime you have a logarithm in your original statement, so this is my original statement, anytime you have a logarithm, you have to check your answer. Okay, remember, when you have logarithms, both this number, the base, and that number, my argument, have to be positive. So I have to check. Always check. Oh, that is not how you spell always. Always check. So we're not saying that this number has to be negative or can't be negative. We have to make sure that together is not negative. So 6 plus 4 equals 10, we're okay. Okay, so let's just say, for argument's sake, if our answer was x equals negative 2, well, when I plug it in, I get positive 2. That's still okay. Again, it's not that x cannot be negative, it's that that whole argument cannot be negative. So if I add negative 6, then that answer is not going to be okay. All right, so again, you're plugging into the argument to see if it works, not if x is negative. X can be negative, just when you plug it into the argument. And you don't have to plug it into the whole equation and plug these into your calculator and all that, no. Just this parenthesis right there we have to make sure is positive. So we have to check that every single time we have a log equation. Okay, so the next one, okay, I'm going to throw you right into the fire. Why don't you pause the video and solve that for x. Okay, I hope you paused it and you solved. So now let's check your answer. So again, I have a log equals a log. They're the same base, so I can set the arguments equal. So now I'll just solve. We can subtract 7x from both sides. So x is going to be 9, because I'll subtract 11 from both sides. Again, I have to check that 9 is going to make this positive. So that's going to be 72 plus 11, that's a positive number. And this is going to be 63 plus 20, that's going to be a positive number. So we are good. Okay, so always check your answer. Now, you're not always going to have that. Here, I have 3 logarithms, and ln is just a logarithm like anything else. Don't get confused when you see ln. It's still just a log. It just has log base e instead of the last one had log base 4. Okay, so it's just log base 6, I'm sorry. So this is just log base e, but I cannot use the property. What you cannot do, and don't write this down, you cannot just say, oh, 2x plus 6 equals 4 plus x minus 3. I'm just going to get rid of those. Okay? No, you cannot do that. That is not what the property says. If you go back and look at the property, you have to have this be true before you can do that. So again, you are not just canceling out logs or subtracting logs or dividing logs. That is not what we are doing. We have to get it to look like this so that we can do this to help us solve. So I have to first try to get it to be a log equals a log. So I can use a property here. Okay, we know our log properties. If I'm adding 2 logarithms together with the same base, I can divide, I'm sorry, that's terrible of me, I can multiply their arguments. So natural log of 4 plus natural log of x minus 3 becomes natural log of 4 times x minus 3. Okay, so if you're adding 2 logarithms, you can multiply their arguments. So that's just a property from our last test. Now I have it in the form I need it. Logarithm equals a logarithm. I can set the arguments equal to one another. So once you get it in that form, log equals a log, then you can set the arguments equal, and now I can solve this. So I'm going to distribute that 4, and then I will continue to solve. And again here, x equals 9. Again, let's do a quick check. 9 here, yep, that'll be positive. 9 minus 3 is 6, yep, that's positive. And we are good. Okay. So sometimes you might have to use your log properties to get it to be in the form that we need it, but we're still using the same principle. Okay? Alright, now this one's a little tricky. Okay, you have to use a few properties here to do this. So the first thing I see is I have a number here out front. Well, I can't combine any logarithms until I get rid of that. So we're going to bring it over and make it an exponent. So that'll become log base 4, oh, I'm sorry, not base 4. Log of 4 squared plus log of x minus log of 8 equals log of x plus 10. Okay, so that's going to be log of 16. Okay, and now we're just going to keep condensing these together. You condensed logarithms on your last test, so we're doing that same thing. We're condensing. So we're going to have 16 times x, because I'm adding those 2 logarithms. And I know I'm doing this one step at a time. If you can skip a few steps, that's okay. I just don't want you to get confused. So now I'm subtracting these logs so we can divide their arguments. So 16 over x becomes 2x. And now I'm down to the form I need it in. Log equals a log. So now, since a log equals a log, I can set my arguments equal and solve for x. Again, a quick check. 2 here, that one's good. 2 there, that one's good. There's my answer. And I'm putting the check mark there to show you that I did check to make sure that my argument was positive. Okay, I'm going to do one more with you. Then I'm going to ask you to do the last 2 in the video there on your own. Okay, so this next one here. Okay, now with the last one we had subtraction, but that reduced, so we ended up not having a fraction when we went to solve, and that's not going to happen here. That fraction's going to stay in there, so I'm going to show you what to do with that. So again, I need to combine these 2 logarithms together. So it's going to be x plus 6 over 4. Because I'm subtracting the logarithm, so that means we divide the arguments. So now I have a log equals a log, so I can set the arguments equal. Now, to get rid of the fraction, I want to multiply by the, and if you were all here, I would wait for somebody to say it, but you're not. I'm talking to an empty classroom, so instead I will say it. The answer is you'd multiply by the denominator. So I'm going to multiply by 4 on both sides, so that gets rid of the 4. Do not distribute that 4 through my numerator. No. We're not multiplying by 4 over 4. We're multiplying by 4 over 1. There's only one 4 there, and it is going to cancel out with the denominator. That's why we multiply by it, so that we get rid of it. Don't then distribute. So I'm going to end up with 4x equals x plus 6. So if you ever have a fraction, when you're solving, just multiply by whatever the denominator is and get rid of it. So then I will have 3x equals 6, so x is 2. Again, a quick check back up into the original to see that that will be okay. It's not going to make anything negative. So my answer there is good. Okay? Alright, on the next slide you have 2. I want you to pause the video and try them. And then in a few seconds, the answers will magically show up. Okay, so go ahead and pause and give them a shot. Okay, there they are. Okay, there are your answers. Now, we're going to start with the orange one, because I feel like probably more of you got the orange one right than the blue one. So if we look at the orange one on the right, again, we are subtracting our logs, so that means we're going to divide. So once you set the arguments equal, you want to multiply both sides by that denominator to get rid of it. So I'm left with x minus 8 equals 18. Add 8 to both sides, and that 26 will make it positive. Now the blue one. Of course, I do the easy ones, and I leave the hard ones for you guys to do. So this was the first one. When you multiplied, you ended up with x squared. So what did we have to do? We have to factor. Okay, so you have to get it equal to 0 first. That is a key of this, is you have to get it equal to 0. Okay, some of you I know like to factor this by saying, well, this is x times x plus 3 equals 10, and then setting both equal to 10. Do not do that. That is bad algebra. You're making up your own algebra rules that you cannot do. Okay, so you have to get it set equal to 0. Then we factor, and remember you need two numbers that multiply to give you negative 10, but add to give you 3. So that would be 5 and negative 2. And when I solve, one of them will not work. Now again, it is not because 5 is negative. It is because when I plug it into my argument up here, that is negative, and my argument there, that is negative. That is what matters. So when you get down to two answers, don't just say, well, any ones that are negative will not work. That is not the case. You have to plug back in and see which ones don't work. Okay? But 2 will work. 2 plus 3 is 5, and 2 is 2. So those are positive. So that one will work. And again, it won't always be that one works and one doesn't. Sometimes both will work. Sometimes both will not work. Okay? So that is the first part of these notes. When you have a log equaling a log, what do we do? Well, we just set the arguments equal. So that is the first part of this. Okay? The next video is going to be finishing up the notes, and you can see from your next one, that's when you only have one logarithm instead of two. What do we do? Okay, so that's what the next video is on. So if you want to watch it right now, after this one's done, that's fine. If you want to go to the homework assignment on the back, it's half this first part and half the second part. So if you want to do the first 3 problems from the homework, it's just like this. Then you can watch the second video and do the second 3 homework problems on that, however you want to do it. Okay, and as always, if you have any questions, just email me, or I'll be going over this with you again once we get back from break.